Yo, what's going on, everybody? Today I'm going to be creating part 3, 4, and 5 because the last 3 days I haven't uploaded. But it's not because, hold on, my gain is kind of high. Hold on. The reason I didn't upload was because I had a lot of interviews, a lot of meetings, and I don't know, I've just been very busy. And also, I did record, the files just crashed. So it's like, what can I really do about that, right? Wait. All right, so now we're doing product of array except self. Given an array of nums, return an array answer such that answer of I is equal to the product of all the elements nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs an O of n time and without using division operations. Okay, so constraints. Uh, all right, so if we look at the example, we get 24, 12, 8, and 6 as the output. So the product of all except I. So if I equals 0, it would be the product of 2, 3, and 4, which is 24. If I equals 1, it would be the product of 1, 3, and 4, which is 12, and so on and so forth. This is pretty straightforward. So already, my thought process is you, we grab I, we get I, and then we just literally have to multiply everything else and put it into another vector. So like we'll hold I, then do the rest times the rest. Then we have to insert into new vector and then return that vector. So my thought process is we're returning a vector. So already do this. Just to get that out of the way, we're going to be using a loop here. We can't do two loops because O of n. So we need one pass through a loop or two different loops. So if I want to multiply every number but the number we're on, we would do. So let's just use this first example. This is actually a decent example. So we don't want to multiply the 1. We just want to do the 2, the 3, and the 4. So if we're starting at index 0, we want to multiply everything after that index. And then store it in another vector. So I'm just going to kind of reverse engineer here. We know we're going to be getting like a sum, int sum. Then we're going to be doing result. Now, all we need, sorry. Now, all we need to do now is figure out how to get sum. And we can work from there. And then I'll handle edge cases after. So to get sum, we have to multiply every index except for the current index. And we can't use a nested for loop, which is probably like the easiest way of doing this. So I'm thinking I'm gonna just write out a for loop real quick just to like. We'll do like sum equals, it would have to be like sum times equals nums of I. But we can't use the current index. Could we do a while loop? Okay. If I do multiple loops, is that still O of n? If I do multiple loops, it's not nested. Is that still O(n)? Okay, so we can just do like a bunch of loops. But we don't know the size, so that's gonna be a bottleneck. And then some, we have to initialize some as like 1 or something. We'll do um so we have our size. This is an easy problem. I don't understand how I'm getting like stumped. Oh wait, we can do this backwards. Okay, we can't use division. So I was thinking we just multiply them all and then divide them by the index of the other one. But we can't use division. So we can only use multiplication. So we can't go reverse. And we can't do nest. Damn, these constraints are like what makes it difficult. Because like if I could do a nested, easy. Or if I can divide, easy. We can do division, but can I multiply by a double? Nah, I don't want to do that. I feel like that's the same thing. Because like, because if we do 2 times 3 times 4, or let's do a better example. If we do like 1 times 2 times 4, we'll get 8, right? Considering we're on like index 2, which would be 3. So we'd get 8. But if we multiplied that additional 3 in there, we'd get 24. But if we converted it into a double and we multiplied it by a double, it would be 0.3 times 24, which is just 8. Because it'll go to the nearest whole value. I don't want to do that though. I feel like that's cheating. Okay. This is a hash set problem because we know this because of the way this shit was set up. So I guess we got to use like some kind of hash set. Does the order matter? Follow up. Can you solve the problem in O of 1 extra space complexity? So we're gonna have to use a map or a set or something. So let's do this. I'm so stumped. This is an easy problem. What do I do? I know we have to use hash sets or maps or whatever. I'm so stumped. This is an easy problem. Like, this shit is so straightforward. Okay, I have an idea. I think. So what I'm thinking is I can use an unordered set and I can use a for loop. I can put a number inside the for loop based upon the index. So like for the first index, we'll put 1, right? The value 1 inside the unordered set. We'll put 1 inside the unordered set. So now 1 exists inside the set. And then once 1 exists inside the set, we can no, that requires looping. If we fill up this set with 1 through 4, we can still access it like an array using index values. I'm gonna just fill this up first, just to get my brain out of there. Okay, so we have an unordered set with our values in it now. So now what can I do? We can do okay, let me try something. Let's try I always get this shit backwards. So I is at 0. So the index would be 1. So we need to multiply 2, 3, and 4. We can probably do this, to be honest. Wait, I think I might have like figured something out. You're like if we could do like nums of size -1. That'll give us the 4. And then we can multiply that by this is still, damn, what am I doing? What am I doing? 12, 8, and 6. Wait, I need to draw, bro. Uh, drawing board. Okay. So, can I use text? Perfect. All right, so we have nums equals this and output equals this. So we need to get this and multiply. We can't multiply this one, but we have to multiply this one, and this one. And that gives us 12. And then we have to move on to this one and do the same thing. We have to multiply 1, 3, and 4. So we have to go back. And then when we get here, we have to do these two and then multiply by that one. And we can only use one for loop. So we can only do this in 1, 4. But I can't even, I'm using a mouse right now. In 1 for loop. This is our constraint. We can only do this in 1 for loop. So I'm thinking we can I grab these? Okay, yeah. I'm thinking okay, 1 is self-explanatory. I want to do like 2 or 3 because it's in the middle. Like let's say we have 2 up and we want to multiply these 3. I would have to like reset the loop. Okay, I have an idea. Let's say we're using I as our variable, right? We can incorporate J. Okay? Hear me out. We can have a J. And so our size is 3. It goes from 0 to 3. And so we can do, since we know our size is 3 and we have these 3 numbers, I guess 4 numbers, if you count that. Let me move this back. We have these 4 numbers and these are the indexes. 0, 1, 2, 3. And we need to do this one. So that result should be 3, it should be 12. So we should get 12. So what I'm thinking is we pass this through the loop and we grab the index. So we grab this 1 right here. and we reset I, okay? So we set I equal to 0 until it goes back. And we have j equals 1. So we do if it equals, we can do like if I equals j. We'll skip. And we'll do like times equals, we'll do like sum. This is so bad. Sum times equals num I, and we'll have a third variable called k. And whenever k equals size minus 1, whenever k equals size minus 1, we break. Otherwise, we'll be in an infinite loop. Does that make sense? I hope that makes sense. All right, let's try this. I'm gonna write it down first, just to like try to make this clearer. So we have our for loop. Reset loop once for each index. J holds index once k equals size minus 1, break loop. The only bottleneck is going to be we need another j condition. It's going to have to go over j at least once. Okay. I'm like way in too deep, bro. I'm not going to lie. Let me just do this. Sorry. Do this. All right, so we have this right here. We'll have int j equals 0. Okay. So we're starting off at 0. So we'll do if I does not equal j. We'll do sum times equals nums of I. Okay. And then we will do we only do j plus plus if I equals size minus 1. We can do j plus 1 or j plus plus, and then I equals 0. Right. And then if j equals size minus 1, we can do, once j is 1 less than the size, we need to break the array. Right? Because if our size is 3, why would we break at 2? Huh. Oh wait, no. we'll just say break. Would this work? And then we just do I'm just winging it, bro. Alright. So where's our logic wrong? Our output was 1, 2, 3, 4, 1, 3, 4, 2, 1. Okay. I'm pushing back result every single time. That's the issue. That's the issue. So once we do this, we can do that. Right? We're getting warmer, guys. So we're just missing a 6. We're missing 2 times 3 times 1. We're missing the initial. Okay, so one of these is wrong. So it's either going to be this one. Okay, that's just wrong. Wait, we got case 1 down. The only problem here is we're missing a negative for some reason. Okay, so why don't we have a negative? So in their case, it should be minus 1 times 1, which is minus 1. And then minus 1 times 3, which is 3. And then 3 times 3. That doesn't even make any sense. How is that negative? How did I get negative? Alright, let's pass that through, right? So we'll do minus 1. So let's say our index is 3. Or our index is 2. So I equals 2. So that means j is also going to equal 2. Oh no, I is going to be 0 and j is going to be 2. So we know on our first pass, we do minus 1 times equals nums. Which is... we do 1, so this is going to be minus 1. We go through again. We get minus 1 again. I equals j, so we just skip over that. So we have minus 1. We do minus 1 times minus 3, which should give us 3. And then 3 times 3, which should give us... Huh. I don't understand how this isn't working. We're getting all the values. If size minus 1, if I equals size minus 1. What if I do this just to like, I just want to see what it'll give me if I do that. So then it reverts. There's an edge case that I'm missing here. It's not multiplying. It's either doing, we're either skipping the 1. We're not skipping the 1 because I equals 0. So 1, 2, 3. For some reason, we're skipping 3. Or like our multiplication. Alright, I'm gonna just Because it's kind of fucking with me. Alright, so using this logic, in theory, we should get, right? Yes, for that input, the correct product, so output y. For each index I multiply, but your code won't produce that because you're resetting I equals 0 inside the loop, which breaks the normal for iteration and risks an infinite loop unless j that approaches O of n squared for each index. You're rescanning the whole array. Oh my god. The usual O of n is with prefix and suffix products. What it prefix or suffix products. How do I get a prefix product without resetting the array? Bro, I'm throwing in the towel. I feel dumb. So left pass prefix equals 1. Result of I equals prefix. Prefix times equals nums of I. Right pass suffix equals 1. So from here they're doing I equals 0, and then they're doing I less than n. N is the size. Vector n result n comma 1. So the result is n comma 1. Return result. And n is the size. So size comma 1. So they're initializing everything to be 1. And then they do result of I equals prefix, which prefix equals 1. And then they do prefix times equals nums of I. Product of all elements before I. And in this case, I equals 0. That doesn't make any sense. Or am I tripping? How do you get before 0? So we do I plus plus, we get 1. So result of I equals prefix. Prefix is equal to times equals nums of I. So example, -1, 1, 0, -3, 3. Left pass result. 1, -1, -1, 0, 0. It's automatically giving this a 1. This is getting the prefix of it, which is -1. This is being multiplied by that, which is also -1. And the rest are getting multiplied by 0. And then when we pass to the right, this is getting multiplied by 0. This is getting multiplied by 3. And then multiplied by 3 again. There's 2 negatives makes a positive. Bro, how are you even supposed to solve this shit, bro? Ah. Bro, it sounded like an easy problem. Like, this shit sounded like it wouldn't have been hard. Bro, I keep getting humbled video after video. I gotta lock in.